Welcome back, and in this video we are going to look at the expressions, or what we can just call assignment statements, which is the last statement that we've not looked at. So let's start by looking at the expression. I'll just call this one expression. We looked at expressions. I think that should be unit number 5 that I've given you. Expressions, we identified them to be of 3 types. The first type is arithmetic, where we are looking at expressions involving addition, subtraction, multiplication, and division. And of course, we also have modulus. Apart from the arithmetic expressions, we have other expressions such as logical expressions and the relational expressions. We are going to be looking at them as we go, but for now I think we are going to mainly focus on the arithmetic expressions. When we look at the other types of statements or other types of block of codes, we are going to introduce formally the relational expressions as well as the logical expressions. So let's get started by looking at arithmetic expressions. You should remember that in terms of statements, we said we have input statement, output statement, declaration statements, and assignment statements. But in most cases, assignment statements are associated with expressions. In most cases, we have an expression, and the result of the expression is assigned to a certain variable. So when you're talking of expressions, generally we'll also be talking about assignment expressions, or assignment statements, I mean. So expressions is all about processing. It involves the CPU. It involves the processing part of our computing system. Okay, so let's look at some few examples. We are going to start something very simple without using any variables in it, just simple expressions. So C++, we can use C++ to have expressions such as maybe 10 plus 3. So this is an expression. We are having this as an expression. So this expression, we are adding 2 numbers, and immediately the result, we want that result to be displayed. So that one is an expression. Let's try to compile our program, and let's try to run our program. So we are going to get 13. So this is an expression. Sometimes you can put your expression in a bracket like this to show that it's one thing. So here we are indicating that this is one thing. So we have bracketized it. So if you run it, we are going to get the same result. So and of course, if you have a mixture of operators, you may want to bracketize to prioritize, the same way we've been using maybe operators in mathematics, like maybe following the rules of Bodimas. So here is our first expression. We are going to have other expressions. So let me just have this one copied, and let's try to have it here. So apart from that, you can subtract, you can multiply. So multiplication, we use the symbol, and you can also divide. So we use this symbol to divide. So these are expressions. And what are we going to get? 13, this minus this, that should be 7, this should be 30, and this one should be somewhere there. So maybe 3 point something. Let's see, is it going to give us 3 point something? I don't know. So it's going to give us 3. Why is it giving us 3 instead of 3 point something? 10 divided by 3, we should get 3 point something. So here is an explanation for that. If you are dividing numbers, you are dividing values, and both the divisor and the the number on top or this one below, all of them, if they are integers, all operands are integers, the final result will be integer. So you cannot divide integers and get a real number. That does not work. So in C++, if you are dividing integers, you are going to get integers, full stop. So that's why here we are only getting 3. The decimal part is disregarded. If you want to have something which is not integer division, then you need to make sure that the number, either the first operand or the second operand, is written in such a way that it should show decimal. So it's either you can have 10.5, 10.0, which is the same as 10, but by putting 0.0, now our compiler is going to treat this one as a float number. So any division of that involves a float number and something else, the final result is actually a float number, or a double number divided by whatever, we are going to get a double number. So here we are going to have a double at the end of the day. So we call that one the float division or something. The other one is integer division, and this one is float division. So if we run it, okay, compare it first and run it, and we are going to get, this one is integer division, but this one now is able to give us the float. Okay, that's cool. And the last one that we are going to have under this group is what we call a modulus. This one. So this one is a modulus. And with a modulus 10, modulus 3, a modulus symbol, this percentage is written as a modulus. Modulus symbol is used to get a remainder. So it will show you remainder and not the quotient. Here is showing you the quotient, like this one is showing you the quotient, is disregarding the remainder, but here is disregarding the quotient, is only giving you the remainder. So we use the modulus to get a remainder. So 3 into 10, it goes 3 times, and the remainder is 1. So this expression is going to give us 1. If we run it, the last one is giving us 1. So that's those are basics of arithmetic expressions. Apart from having these ones like this, we can actually get the values from somewhere else. We can now combine so many things together. We can combine so many things together, and we have, as we have said, you can use operators, brackets, etc. to group your expressions, whatever we can do. But I want us to have variables instead. So you can have variables like a, maybe a is equal to b, a is equal to 20, and b maybe it's given a value of 30. So we can have this, and maybe we can also have another variable which is sum, and this will be a plus b. So this is an expression. We are having expression this side, and the result of that expression is being assigned a value sum. So we are declaring a variable sum, and we are having expression. You should remember that expressions can only appear on the right hand side of the assignment statement. You cannot have expression this side. Here you only have one thing, you only have the variable. When we are looking at the assignment statements in our last class, we emphasized the use of variables, or how we can interpret the equals, that this sign is not equality sign but assignment sign. Therefore, a plus b should appear on the right hand side. So if we can have this one, and we display maybe something like this, sum equals, maybe something like that, then sum, this one is going to show us the sum of the two numbers. So it will say sum equals 50. We are getting 50, which is a plus b and we are keeping it here, and we are displaying it here. So that's expression. We can modify this program, for example, to say, okay, apart from this, we can make a simple program that should be getting values from the user. So we have just declared variables a and b, and immediately after that, we need to give values to a and b. We can do so using cin. So we can say cin a and cin b. So here we have our statements. Now, if we run our program, it should be able to ask us to enter a value there. We can give a value of 40, and it's also asking us to get another value, maybe of 50. Then it will give us sum is equal to 90. So we have made it more interactive. We can give it values. It will be able to add those values for us. But we can also make it as before. We can also make it more descriptive by saying maybe enter first number here. Maybe that will make it more descriptive, and maybe just putting something here. So the same should come here. So this statement will be shown, and immediately it will be asking you to enter that value. And we can also show similarly here to say enter second number, and immediately we are going to show it. It will ask us to enter the value here. So with those modifications made, now if we run our program, we are going to have at least some information describing us what we should enter here. So we are entering 50, and we are entering second number as 100, and we are going to get the sum is equal to 150. So that's how you actually use expressions. And here we've just shown you a simple expression, adding numbers together. You can use it to subtract numbers, to multiply numbers, or to do anything. Reaching this far, that now we have shown you how you can use the expressions, you are now on the right path of coming up with the programs or solving some basic programming problems out there. You can have a program that should be able to do some averages, or maybe a program that should calculate the area of the circle, etc. They all involve expressions. So in our next video, after introducing you to another environment for coding, we are going to go into some simple programming statements, programming problems that we can solve together, so that we can show you how you can use all these statements that we've covered so far together. See you in those videos.